Robert Jennison Van de Graaff was born on December 20th, 1901, in Tuscaloosa, Alabama. His mother was Minnie Cherokee Hargrove, and his father was Adrian Sebastian Van de Graaff. Robert attended the Tuscaloosa public schools, and then attended the University of Alabama, where he received a B.S. degree in 1922 and an M.S. degree in 1923. Both degrees were in mechanical engineering. After graduating from college, he worked for the Alabama Power Company for a year as a research assistant. He studied at the Sorbonne in Paris from 1924 to 1925, and while there attended the lectures of Marie Curie on radiation. In 1925, he went on to Oxford University in England as a Rhodes Scholar. At Oxford, he received a B.S. in physics in 1926 and a Ph.D. in physics in 1928. While at Oxford, he became aware of the hope of nuclear experimenters, such as Ernest Rutherford, that particles could someday be accelerated to speeds sufficient. By disintegrating atomic nuclei, much could be learned about the nature of individual atoms. It is from these ideas that Robert Van de Graaff saw the need for a particle accelerator. In 1929, Van de Graaff returned to the United States to join the Palmer Physics Laboratory at Princeton University. In the fall of that year, he constructed the first working model of his electrostatic accelerator, which developed 80,000 volts. Improvements were made to the basic design, and at the inaugural dinner of the American Institute of Physics, a demonstration model was exhibited that produced over 1 million volts. While Carl T. Compton became president of Massachusetts Institute of Technology, Van de Graaff was invited to come to MIT as a research associate. Van de Graaff constructed his first large machine in an aircraft hangar in South Dartmouth, Massachusetts. The machine used two polished aluminum spheres, each 15 length in diameter, mounted on 20-foot-high insulating columns, which were 6 feet in diameter. The columns were mounted on railroad tracks that boosted the spheres to 43 feet above ground level. The machine had its debut on November 28, 1933, and was able to produce 7 million volts. This accomplishment was reported in the New York Times for November 29, 1933, in a story titled, "Man Hurls Bolt of 7 Million Volts." In 1935, Van de Graaff received a patent for his invention. He was guided in the preparation of the patent application by Carl T. Compton and Vannevar Bush, who was the vice president of MIT. Van de Graaff also worked with John G. Trump, a professor of electronical engineering at MIT, and with William W. Buckner, a professor of physics at MIT.
My specialty is general cardiology. I practice all areas of cardiovascular medicine, including prevention and treatment of vascular diseases, cardiac diseases, rhythm abnormalities. One of my specialties is insertion and maintenance of implantable devices such as pacemakers and defibrillators. I also specialize in cardiac imaging and cardiac testing. A
medical Van de Graaff used to produce X-rays for treating cancerous tumors with precisely penetrating radiation was first used clinically in 1937 at Harvard Medical School. In 1936, Van de Graaff married Catherine Bowden. They had 2 sons, John and William. During World War II, Van de Graaff was director of the high-voltage radiographic project, along with William W. Buckner. He directed the adaptation of the electrostatic generator to precision the radiographic examination of U.S. Navy ordnance. On December 19, 1946, Van de Graaff and Trump formed the High Voltage Engineering Corporation in Burlington, Massachusetts. HVEC was formed. For the commercial production of particle accelerators, Dennis M. Robinson, a professor of electrical engineering from England, became president of the new corporation. John G. Trump became technical director, and Van de Graaff became chief physicist and a board member.
Two beams of protons, one of the building blocks of matter, will circulate in opposite directions around the underground ring at close to the speed of light. The subatomic particles will be smashed together in 4 huge detectors placed along the 27-kilometer ring, generating showers of energy and matter. Physicists hope those will include the elusive Higgs boson, dubbed the God particle. According to the standard model of physics, this ghostly particle created in the moment following the Big Bang is responsible for assigning mass to elementary particles.
HVEC became the leading supplier of electrostatic generators that were used in cancer therapy, industrial radiography, and in the study of nuclear structure. In 1951, Louis W. Alvarez of University of California, Berkeley, rediscovered the tandem principle first developed by William Burnett in 1957. A tandem Van de Graaff machine accelerates a negatively charged particle, typically having a charge of -1 or having one extra electron, toward a positively charged terminal. As the particle passes through the terminal, electrons are removed from the particle. This causes the particle to become more positively charged and therefore accelerated away from the positively charged terminal. When heavy ions such as gold or uranium are used, as many as 25 to 30 electrons may be removed. The high voltage terminal is thus used to accelerate the ion twice. In the 1950s, Van de Graaff invented the insulating core transformer. The insulating core transformer generated high voltage direct current using magnetic flux rather than electrostatic charging. Van de Graaff also devised many methods of controlling particle beams during and after acceleration so they could be adapted to individual research requirements. Using Van de Graaff accelerators, physicists accumulated vast quantities of information on nuclear disintegrations and reactions. This data led directly to sophisticated theories of nuclear structure. Van de Graaff remained an associate professor of physics at MIT until 1960, when he resigned to devote himself to increasing the involvement with HVEC. Robert J. Van de Graaff died on the morning of January 16, 1967, in Boston, at the age of 65. At the time of his death, there were over 500 Van de Graaff particle accelerators in use in more than 30 countries.